Okay, so it was a little different back in 1969, but Eden Prairie was a location of an airport. Let me put this on to terrain. All right, here we go. And here we go. So this is the Minnesota River Valley. And I was standing, I actually went back and a few years ago, found the spot I was standing, and it was right here on this bluff, looking into this valley. Now, if you go here, you can see there's another side to it over here. And if you look back here, you're going to see this is what's an underfit river. An underfit river is where the modern river is diminutive relative to the channel that it's flowing in. And the channel was part of what they called the spillway of Lake Agassiz, which was a gigantic meltwater lake that formed in that interval that Graham was just talking about. So this is the modern Minnesota River, which is a fairly substantial river, probably close to the Colorado here that runs through Austin. But you can see the channel. The channel is huge relative to the river. A few geologists have worked on it and concluded that the meltwater flow through here was 4,000 times greater than the modern flow of the Minnesota River. So anyways, I was standing here looking out into this, and what I saw was the modern river entrenched within a couple of banks, and then I'm looking at this huge channel, and I just had this impression that, was this a huge river channel? You know how, because see what I was looking, 3 miles across, there's another set of 200-foot high bluffs matching the ones that I was standing on. And then below me was the modern Minnesota River with its banks, which were like miniature versions of the bluffs. Now, it was a full decade before I actually came back to the idea as I was beginning to learn more about catastrophism, which was still very much in the seminal stages back in the, say, the 70s. You know, we've learned so much more about the catastrophic history of this planet since then. But then I began to think, well, and this was before I even knew about Glacial River Warren, it was called, which was the flow through here. And you can actually, Graham, we went there. If we chased.
We did indeed.
We did. Right up here by Ortonville is Big Stone City. So this is the southern outlet of Lake Agassiz. And this was one of the many outburst floods of gigantic flows of meltwater coming off the ice sheet. Big Stone City. Now, when you look at names of lakes and towns and places, oftentimes there's clues, like Big Stone City and Big Stone Lake. If you go there, there's big stones laying all over the landscape that were flushed out in this catastrophic draining of Lake Agassiz.
Because these drainings would have involved not just water, but icebergs.
Yes.
Turbulent flows of water filled with icebergs the size of oil tankers. And inside those icebergs, locked up, are huge chunks of rock. And eventually the iceberg melts and it releases the rock, and that's how you get the big stone. Yeah.
And then the last place we went, Graham, was the potholes at St. Croix Falls. I'll zoom in here. And this is an interesting place. There's a constriction in the bedrock. This is hard basalt bedrock. And when you have water flow coming along, it's got a conservation of volume, so that if you have a narrow part of the channel, the water coming in as it's going into that constricted channel speeds up, because if you take measure of the water flow at any 2 points along the channel, it's going to be the same. Whether it's a wide channel with shallower water moving slower or a narrower channel with deeper water moving faster, the discharge through that channel is going to be the same. Well, what happens is if it comes into a constriction, it has to speed up then. When it speeds up, it becomes more erosive. And that's exactly what happened right here at Taylor's Falls. And right here at Interstate Park is a series of gigantic potholes. Now, these potholes are evidence of intense turbulence within swiftly moving deep water. In a minute here, I'll pull up. I've got a great shot. When Graham and I were there, I was in the bottom of one of these potholes, and Graham is peering over the rim. And it's a great shot because you can really get the sense of the scale. I'll pull it up here in a second. But if we go, where did this water come from? This water came from right up here. Lake Nipigon. That was the source of this water. And when you go south of Lake Nipigon, the whole landscape is channel scablands, just like Graham and I were seeing out in Washington. Mm-hmm. And this is very convincing evidence of really catastrophic water flows. And I've always thought it's interesting, or at least for the last decade or so, that if you look at the elevation of the land here, you look at the elevation of the land over here, it's the same. But if you go in the middle here, it's 500 to 1,000 feet lower. What happened here, there was a major discharge south out of Lake Nipigon, came down through.
And I think we should add that Lake Nipigon was discharging because it was filled up with water that came out of the ice cap and filled it up.
Yes.
Yeah. What is the conventional explanation for these massive bluffs that are very far apart from each other with a relatively small river running through the middle of it?
Try as I might, I've never found an explanation. But you can look here at this. And this is pure what you call scabland, which is the result of major erosional, intense erosion, cutting out. This is a coulee, but
it looks like somebody's just been picking scabs off the skin of the land, and that was these water flows rushing through it, filled with icebergs and whole forests ripped up by their roots. Naturally, it looks like torn up scabs.
And so it's your assertion that this all came out of the cataclysm, that this all came out of the impacts. Comet impacts.
James Teller, geologist, has dated these flows 12,800 to 12,900 years ago.
And how has he done that?
Radiocarbon dating primarily, by finding if you have a flood and it's picking up anything organic, bone, wood, whatever, and you look in those deposits and you sample, and the samples, let's say because it's a flood, what it's going to do, it's going to pick up younger and older material, because it's washing away, it's excavating other land. And so what you do is you get enough datable material, and if it keeps coming up that the maximum age is a given age, that's probably when the flood happened, or a minimum age rather, not a maximum age. In other words, a flood might pick up stuff that's 15,000 years old and 12,000. Well, when did the flood happen? At 15,000 or 12,000? So what you do is you look for the youngest datable material, and that should usually give you a pretty good idea of when the flood happened. So James Teller has dated this overflow here, and again, it comes out perfectly consistent with the Younger Dryas.